did not have a weekly quiz. You're one of the lucky classes. Because all my other classes had weekly quizzes yesterday. On the story.
There's no way I would have checked for that.
So I sent you emails. So I had my stats and my calc and my pre-calculus had all the weekly quizzes.
I'll be like,
This is chapter 6.
No, I would never know.
And when I say, I want to bring one more point up. When I say, are you ready for pre-calc or ready to not pre-calc? You have to be ready. When I say you're ready, you have to be ready to go at a decent pace. You know, and that's why I don't know what the schedule's going to bring for next year, if they're doing this modified block or not. But right now, I looked at the schedule for pre-calc right now, and we're 2 weeks behind. So some of it might be covering 2 to 3 sections a day. You know, so that means we're going to be cruising and to get caught up there. So, okay, I don't think you've dealt with system of equations before, have you? System of equations instead of 2 equations. And what we're going to do with these set of 2 equations is find out where they intersect. Okay, the system of equations instead of 2 or more equations. I should say more because we might have more than 2 equations. We might have 6 or 7 equations at a time. If the graph of each equation of the system is 2 variables, is a line, then the system is a linear system. So like here, we have a linear system. Both equations are lines. Both equations are lines. A solution to the system of equations is a set of values for the variables that makes all equations true. In other words, if I find a point where they intersect and I try it into both equations should be true. It should work in both. You can solve system of linear equations by graphing the equations. The points where both or all the graphs intersect represent the solutions. Okay, get y by itself on both equations. Let's start with this one. Get y by itself on both equations. Not too real hard. Correct? Graph the first equation. Graph the first equation. Y that's the first one, right? Started at 5, my y-intercept was 5, I went down 2 over 1. The second equation. Start at 2, go up 1 over 1. Looks something like that, correct? What are the intercepts? 1, 3. Okay. That is my solution. You can check your solution. What I mean by checking your solution is this. Going back to the equation, this means my x is 1, my y is 3, correct? Going up here, 2 times 1 plus 3. Is it true? Yes. Try the next one. Negative 1 plus 3 is 2. Does it work in both equations? Okay, of all the points in the world, all the points in that graph, that's the only point that's going to work in both equations. They make both true. Only point that's going to make both of them true.
So you just is a system then if they both work?
It doesn't have to be. It is a system of equations because there's 2 equations.
Okay.
You might get many answers. You might. This one is all 1 point because they intersect, right? There's other options as we go through these that you're going to have solutions. This one's just one option as you go through. Now you can kind of see the pain on these in a little bit because this was a nice one because you can see where they intersect very easily, right? What happens if they intersect at like 1 1/4 and 2 1/3? It's going to be harder to do, and we got other methods to do that with. But we're going to just start today with graphing as we go through. Okay, we're going to come back to the one on the calculator. Too fast. Okay, classifying. Classifying a system of equations. Linear equations by the number of solutions. A system that has a unique solution, examples 1 and 2, is an independent solution. So the one we just did, the equation we just did, system equation, is called an independent because it was one answer. It has a unique solution. That is called an independent system. So we got independent. Here, they cross at one spot. We have a dependent solution. Is the middle. The dependent solution is one where both lines represent the same line. They put down no unique solution. I put down many solutions. Many solutions, because it's every point on the line. For example, two equations would look like this. If I had this, what, x plus y is equal to 2, and 2x plus 2y equals 4. If those were my two equations, what can you tell me about those two equations? They're the same, just a multiple of 2, right? They're the same equation. If I graph them, they're the same line. How many solutions I have? I have many solutions. Any point that works in that equation is an answer. Because like 1 plus 1 is 2, right? If I put 1 and 1 in here, I'm going to get 4. It works. If I put 2 and 0 in here, it works, right? If I put 2 and 0 here, it works. There's many solutions. Now the third solution here is inconsistent. An inconsistent solution is one where the lines are parallel to each other. Now how does two lines be parallel? And same slope and different y-intercept. If two lines have the same slope and different y-intercept, then they are parallel. This one has no solution. Will have no solution. That means there is not a point that will work in that system of equations. The ones we like the independent ones. If we can get one number to work, that's the one we like. Okay? So this one, if we got to summarize a little bit. Independent, different slopes. And they have different slopes. Dependent, same slopes, same intercepts. Same slopes, same intercepts. Inconsistent, same slopes, different y-intercepts. Those you get 3 cases. You know, you want to look at those cases to be able to tell. Now, what I want you to get to is not even work out and graph. No. Like, if I go to the next page here, here's a system of equations. Not very nice system. If I take my let's take my second equation here, and I'm going to get y by itself. If I got y by itself, I'm going to have this, 2x plus 1. Okay? If I was looking at this system, write down what the answer is. If I was looking at this system, what would my answers? It's classify the system without graphing. If I was looking for a solution, what would my solution be to this system? I want to graph. Okay. So when I say classify, we're looking back at this. We're looking at which of these would it be? No, and I heard somebody say inconsistent. Inconsistent, why? Same slope, different y-intercept. It's 2x, same slope, different y-intercept, so it's inconsistent. So what's my answer? Besides classify as inconsistent, how many solutions does this have? 0, no solution. If I graph these two equations, they're never going to intersect. They're never going to intersect, so no solution. So for classifying this one, so I can look at the equation, be able to tell what kind of answer I have before I even start the problem. Okay, let's see if I can get another one. You try that one. I'll give you a second. See what you come up with. You classify it. If it has a solution, find it. If I was getting y by itself in the first equation, you don't have to do it this way. You can do it negative a over b if you want to. My second equation, I'm just going to do it in my head here real quick. I'm going to get, I believe that's it. Am I agree with me? What kind of system? Independent. Independent solution, right? How do we know? Not the same line and not the same slope, right? Let's graph it. First one starts where?
3.
3, and the slope is?
Negative 3.
Negative 3 over 1, down 3 over 1. Okay, my graph would look, and I don't have a very good graph here. Something like that, correct? Second equation starts where? Negative 7. Go up 2 over 1. That's right, up 2 over 1. I think my points are a little bit off here. Do they intersect at a nice point? I don't know, how about 2, negative 3, does that work? That's what I got. It looks like they intersect right here, 2 and negative 3, but I don't have my graph paper here, so 2 and negative 3, it looks like it intersects, right? Let's check our answer. You can really check them here. 3 times 2. 6 plus a negative 3. 3, does that work? Okay, 2 times 2. 4 minus a minus 3. 7, does it work? There's my point. Independent solution, one answer, we found the answer. You should be able to check your answers very easy by plugging them back into the equation. Okay? One more.
2. Y by itself. Y by itself first.
Be a little harder on that first one. That's right. Is that right? And then what's that one? Second one.
There's 2 steps here.
I think that's right. 2 divided by 4 is 1/2. Okay. Do we need to graph it?
Why? Great. Come.
Why not?
Same slope and different starting points.
Same slope, different starting point. So what's my solution?
No solution.
No solution. What kind of equation is it? Inconsistent. It's inconsistent. Same slope, 1/2 x, 1/2 x, minus 1 plus 1. So it's an inconsistent graph. No solution. Right? 2 parallel lines. So we're going to do these graphing today. You are working at page 118. 1 through 27 odd. I'm going to pick up another base here a little bit. These are 2 systems. It doesn't have to be just 2 equations. You know, if you start looking at stuff coming up here, you know, we will have some equations that have 3, 4, 5 equations. So just for reference. 118, 1 through 27 odd. 27. 27 odd.